ஜிங்க தெரியும்.
யூடியூப் லிங்க் ஷேர் பண்ணி
Sir, Francis, sir.
Sir, yes, sir.
Sir, joined us, sir. Resource person.
2 minutes, sir.
Okay, okay.
Hello. Host வந்து பண்ணணும்.
Sir, good evening, sir.
Hello.
Sir.
Just a minute. Let me check with my speakers. Okay. Bluetooth. Francis, do you hear me?
Yes, sir. Audible, sir. Audible.
Audible, sir.
Sir, shall we start, sir?
Just a minute. 2 minutes. இல்லைன்னா இதில் கொடுத்துருவோம். ஒயர் தான் இருக்கு. Hello. Hello.
Sir, audible, sir. Shall we start, sir?
Do you hear me? என்னோட இது பண்ணுமா? வீடியோ வேணுமா? Okay. Hello. Yeah.
Shall we start, sir?
Yes. Yes, we can start.
One second. So, very good evening to one and all present here. So, on behalf of SWarnandhra College of Engineering and Technology and on behalf of the Department of Mechanical Engineering, I welcome you all for this 6-day faculty development program on recent advancements in material manufacturing and technology. And I welcome you all for the second day. And the first session is by Dr. V. Srinivasan, Professor, Department of Manufacturing Engineering, Annamalai, Chidambaram.
Francis,
And
I'm
the
having
second session
some disturbances there. Mute. Let me ask others to mute. I think we are having some disturbance. Yeah, I request everyone to mute. Please kindly mute your audio. Francis?
One second.
Yeah.
Sir, TSP, college basement.
Reclaim the post and
Francis? Francis?
Sir,
என்ன இது பண்ணிட்டீங்களா? மியூட் பண்ணிட்டீங்களா மத்தவங்கள?
muted, sir.
Remove பண்ணி விட்டுருங்க.
1 second. Okay. Sir, sorry, sir.
No issues. No, it will happen.
So, on behalf of SWarnandhra College of Engineering Technology, Department of Mechanical Engineering, I welcome you all for this second day. The first session is by Dr. V. Srinivasan, Professor, Department of Manufacturing, Annamalai University, Chidambaram. I'm happy to welcome Professor Dr. V. Srinivasan, sir, who is also my guide. I'm happy to introduce him for this first session. Dr. V. Srinivasan, Associate Professor from Manufacturing, completed his doctorate degree from 2004 to 2009 in Annamalai University, having specialization in tribology, polymer matrix composites, engineering metallurgy, and operational research. Overall, with 24 years of teaching and research experience, he has published various research papers in national and international. So 4 national and around 32 international journals, having a H index of 10, published a book chapter named Hybrid Metal Additive Manufacturing, and that the chapter is Advanced Manufacturing for Industry 4.0 by CRC plus Taylor and Francis. And he has conducted various national and international conferences and symposia. Currently, he is guiding 11 PhD scholars, and 8 of them has completed under his guidance. Also, he has got Best Paper Award under the Friction Journal in the year 2016. So, currently he is working on the metal additive manufacturing IN 718. So, with this few introduction, I give over the session to Dr. Srinivasan, sir. Sir.
Okay. Thank you, Francis, for your brief introduction. Sorry, not brief, detailed introduction. Of course, I'm very happy to share my knowledge, what I have gathered with this additive manufacturing. Maybe in the slide, I found some spelling, typographical errors, which is inevitable. Okay. First of all, good evening to one and all. Today, let us discuss about this additive manufacturing. Initially, I was indulged in tribological characteristics of polymer matrix composites, but as the time goes on, it's my turn to switch over to additive manufacturing, which is a developing area, which is a most thrust area in modern scenario, modern period. So almost all of you have know. Just a minute. Yes. Is it visible now, friends?
Yes, sir, visible, sir.
Yes. Let us start with, but everybody knows what is, we can classify the manufacturing as additive, subtractive, formative, etc., etc. And I don't want to give introduction about what is subtractive, machining process involves in forming process. So a brief introduction about additive manufacturing, and then my role as a researcher in additive manufacturing will be shared, and what are the thrust areas that can be researched in additive manufacturing that can be discussed. I have produced, currently I have produced 2 additive manufacturing candidates, PhD candidates. Just now one completed his 5 hours, one is set to submit his thesis, which is a thrust area and developing area, as friends who are willing to pursue research can look into this matter, look into this additive manufacturing. Okay. To start with the brief introduction, additive manufacturing is a method in which part is created by a layer additive process. Instead of removing the material, we are adding the material. If you look at this picture, the using a specialized software, a 3D CAD model. Let me name what is the software and how to create the slicers, everything in the later sessions is cut into very thin layers or cross sections, and then the material is deposited here. Likewise. Then there are different, depending upon the specific method, there are various methods are available in additive manufacturing, either sintering or fused deposition. But usually additive manufacturing machine constructs the part layer by layer until a solid replica of the CAD model is generated. The advantages of this process is very clear because you can develop a complex models, physical models in very lesser time when compared to other machining process, and we can reduce the wastages. But it may be people used to consider this as a eco-friendly manufacturing process, but I'll say there are a lot of things to be done. I cannot, what can I say, convinced that it was a eco-friendly manufacturing process because it involves a lot of energies there. So we need to look after that also. We cannot blindly look into jump into this additive manufacturing. Everybody is doing additive manufacturing. There are some shortfalls in that process that will be discussed if time permits. Okay, and this is the step-by-step procedure. What happens in additive manufacturing? A 3D CAD model is developed and it is sliced, and then we fix the hatching distance like it is shown here, and then it is printed like this, like where we get the final part like this. Okay, and this is very important actually. Just yeah, friends, do you able to see full screen or any other hindrance here? Screen is fully shown, huh?
Yeah, full screen visible, sir.
Okay. This diagram shows how the industries are using 3D printing. It is a data obtained in 2013. Of course, now it is widely used in other areas also. But as far as 2013, the major industry that used 3D printing was motor vehicle, automobile industries, aerospace, then other architecturals and medical, dental, and consumer products, electronics, etc., etc. And for statistically, in 1980, SLA 250 is the first commercial 3D printer. It came into the market for 3D printing. Okay. Just a minute. Wait. Yes.
Sir,
Just a minute. I'm having some issues with the screen sharing. Just a minute. I'm coming. Rectifying. It is. Wait. Yes. So, Joe Bayman shows some 3D plastic models made by selective laser sintering. Of course, it is centering it is wrongly maybe. Developed by Carl Descartes. And this is what actually how the 3D printing evolved from 80s to today's and present day modern scenario. Okay. Yes. What is the use? Why there is need for additive manufacturing? First of all, that means we have to discuss what is the negative part of the subtractive manufacturing process. Because machining is a subtractive process. It begins with a solid piece of stock. The machinist must carefully remove material until the desired geometry is achieved. If it is not achieved or if he made some mistake, then that part will be rejected. So it is an exhaustive and expensive process. And some of the complex parts that shown here, it is very difficult even by forming process like casting and machining. It is a tedious process if you want to develop these kind of components. And you need higher degree of accuracy if you want to make such and such holes, etc., etc. So in this case, additive manufacturing significantly replaces the other manufacturing process, especially the other two manufacturing are subtractive and forming manufacturing, formative. Okay. Yeah. Complex geometries and time consuming in other conventional manufacturing process. That is the reason why additive manufacturing is very important and for the current scenario. Just if you look into this model, is it possible to manufacture through either forming or casting or machining process? How difficult it is? Very, very difficult. So this could be one of the reasons why additive manufacturing is necessary for the is being in the current trend now. And this slide shows a step-by-step procedure how a 3D printing works. It starts with an idea, that is, you want to create a complex, you have some complex model in your mind, how to develop. So you have to develop that model using a CAD. Now a lot of softwares are available. Then once the model is developed, it will be sliced like this. Then the 3D printer uses a hot nozzle to melt a long thin. This is for plastic. Originally, the 3D printing started with plastic materials only. Now it is widely used, and it is 3D printing of plastic is outdated almost. There is no need for 3D printing of this thing, because now metal additive manufacturing replaced everything, because it poses more challenge in production process. So more research have been directed towards the metal additive manufacturing only. And the fifth step is the printer now uses this molten plastic to extrude each of the 2D layers on top one another and create a finished part like this. Just it goes like this, and it make a to and fro motion like this and zigzagly and finish the product like this. This is how a 3D printing works. But most of the people, we can get a 3D printing for even 25,000. We can get it. That is for plastic, polymer 3D printing. But as far as metal 3D printing, metal additive manufacturing, the cost will go around 3 crore or 4 crore, 30 million, 40 million, likewise, in Indian money. So that is another challenge why additive manufacturing is still in the beginning stage in India, a country like India. So some of the types of additive manufacturing are shown here. It may be classified VAT photopolymerization, material jetting, then material extrusion, powder bed fusion, sheet lamination, direct energy deposition. And the most commonly used process is powder bed fusion, especially in India. Whereas let us discuss about what is VAT, because even though if this is important, we must know some introduction about what is VAT photopolymerization. It is a stereolithography. It uses photopolymer resin. Okay. Whereas material jetting, the printer head is above the platform. We can show it in the diagram. The material is deposited onto the surface in the form of droplets. These droplets then solidify, creating a layer, which is building up of layer is repeated here. The third one is material extrusion. It is inexpensive at home 3D printers where the material is drawn through nozzle, heated, and then deposited in a continuous stream. And then the powder bed fusion, even though it is costlier, very expensive, but it is widely used in India, especially you can't get any everywhere. Only one or two facilities in each state, most probably. The two in Chennai or Bangalore, Hyderabad. In metros only we can have this facility, and some other national laboratories they are having this. A layer of powder is applied to the platform. A thermal energy source like an electron beam or laser uses the powder before a second layer is applied with a roller or blade. This layering process is then repeated. And let me come back to powder bed fusion after a few introduction about this sheet lamination. Is a process that binds layers using ultrasonic welding or an adhesive. And TED is one of the most complex type of additive manufacturing. A 4 or 5 axis arm will move around. It's like robotics. Deposited melted metal around a fixed object. The material is melted by an electron beam or laser and then will then solidify. These are the reasons why I said we cannot simply conclude that additive manufacturing is an eco-friendly or environment-friendly manufacturing process. The thermal energy source from electron beam or laser consumes more energy compared to other process. Naturally, that leads to environmental pollution. So that's why we have to be very careful in choosing this additive manufacturing. We cannot choose always additive manufacturing even for simple parts. Only if the parts which are difficult to design and which have complex shapes that can be manufactured, by additive manufacturing. Other than that one, it's better to use. Until this the researchers look into this pollution stuff, I would recommend it's better unless if you don't have any complex shapes or difficulty in design, you better go with conventional manufacturing. But additive manufacturing, the challenges are, one of the important challenges are pollution, environmental pollution, that is different. But other challenges are designing complex design. And in India, the materials, the samples produced by additive manufacturing is very, very limited. That combination, even optimizing process parameters is also very difficult because they are having some standard operating parameters for manufacturing this. Otherwise, they are not changing even functionally graded materials, which is essential for nowadays bioimplants. Is also very difficult using it. In India, it is in developing stage. Whereas in foreign countries, it is already established. But the cost of the people who are looking for research in additive manufacturing, definitely it is the cost is an important factor to be considered once you're looking for this one. And these are the different types of additive manufacturing process. The diagrams are shown here. I can share the slides later to you. Okay. And these diagrams clearly explains how the additive manufacturing has been classified in these seven categories. Yes. This diagram shows a plastic skull implanted by doctors. by an Australian company known as Anatomics. Actually, what happened now, a woman suffered from severe headaches due to thickening of her skull due to biological problem. We don't know what would be the reason. Slowly lost her vision along with her motor coordination abilities. Doctors at University Medical Center Utrecht in Netherlands replaced the top part of a 22 years old woman's skull with the additive manufactured fabricated plastic one. That fabrication was done by Australian company Anatomics. Whereas this is another one. This is the exoskeleton produced by fused deposition melting. Enables a paralyzed woman to walk. Actually, she was paralyzed. She could not walk. But Amanda Boxtel, an avid skier, before she suffered a serious fall on the slopes of Aspen, Colorado in 1992, where she was paralyzed. And she was told that she would never be able to walk again. However, the things happened, changed. The company Exo Bionics and a 3D Systems 3D printed had a bionic exoskeleton, enabling her to walk again along with the other leg movements. These are all special conditions where we can use this additive manufacturing. Okay, these are all challenges. These kind of skulls or exoskeletons are very, very difficult to manufacture by conventional manufacturing process and with higher accuracy, higher degree of accuracy. Yes. This implant production is provided by Materialize and University Hospital of Rotterdam, who presented the case of 24-year male with a large craniofacial. Here, look at this. Traumatic frontal bone defect. And both protective and cosmetic reasons made research of this defect necessary. What they do now, a PMA material, that is polymethyl methacrylate cranioplasty. This is implant was indirectly produced by a stereolithographic model of the damaged area. Subsequently, precise fitment of the implant shortened the operation time. Actually, the operation time also reduced because if it is manufactured by conventional manufacturing process, he has to cut like a tailor. It has to be tailored. Okay, where it eliminated that kind of process need for any corrections and it reduced the operation time. And if you look at this space, the natural count of the skull was re-established and no complications were encountered in this case. These are all some of the important features of additive manufacturing. This is the, okay. What are the recent researches and development in PBF? It is powder bed fusion or laser bed fusion, whatever it is. Here we have presented two case studies. Both the case studies are taken by my scholars, research scholars. One is Subant Entar, who just completed his research, was just defended his Viva presentation. And he got, of course, he got the doctoral degree in this area in the title Impact of Scan Orientation Strategy and Melt Pool Behavior on the Mechanical, Microstructure and Tribological Characteristics of DMLS IN7 alloy. Don't confuse with that. This PBF, LBF, and DMLS are all same meaning. That is direct metal laser sintering. DMLS stands for direct metal laser sintering. And they have also backed the patent and introduced a new scan orientation strategy concept actually. So that is why we have applied for patent. I think, I don't know whether under what condition it is. We fabricated the samples through DMLS process with the different scan strategies. That is, first we take out the scan strategies, that is scanning direction in 67. And then 90 degree we scan it. Then we combine together all the 67 and 90. So we produced three materials and we did our research on this melt pool behavior, microstructural and typological characteristics. Why I'm teaching now, people those who want to get into this additive manufacturing research can look out this paper. Actually, it has been published in Materials is something which is having impact factor 7.5 or something like that. Sorry, Journal of Allies and Compounds. Okay. It has been published in Journal of Allies and Compounds. You can refer this paper, which is a good paper actually. Those who want to pursue research in additive manufacturing can look out this. This is, we took two case studies. One is for mechanical applications, that is aeronautical or automobile applications, and another one is for biomedical applications. The first case stands we took for the aeronautical and mechanical applications. So this is how the samples are like. This is 67-degree samples. This is one kind of sample, and this is 90-degree sample, and this is called, what we name it as, we named this as hybrid sample, where alternate layers of 67. One is first initially we put 67-degree scanning. The next layer we made it as 90-degree. Then again 60-degree, 67. Then again 90. So likewise we printed alternate degrees, which is a new study actually. As far as this in India, maybe I don't think the literature available in this kind of studies are very, very scanty. Where persons who wants to make a research can try these kind of things, because all this, all you have to make a design with the 3D model. You can draw your own 3D model. You can design your own 3D model that can be printed. It's sintered with because since it is a costly process, we didn't optimize the process parameters. Okay. It is sintered with the 400 watts laser power. What we observed is impact of scan orientation on the melt pool characteristics of this material is very scanty. And we also did fretting wear studies on this aircraft wing. Actually, we took a specific application, considering aircraft wing rivet as specific application. So for that, and almost, I think, I reckon all the participants, or when at least 50 to 60% of the participants are junior to me. Maybe just consider this as my advice. If you are doing or if you are pursuing any research, please define a clear problem definition. A problem without problem definition, don't derive the objectives. And definitely, now a new question arises in all the papers. What is the novelty of the author? Kindly consider, kindly take this into account. This is my suggestion or advice to the youngsters who are going to pursue. Please go with strong problem definition. Okay. So this is how 67 or 90-degree samples were printed, whereas this shows alternating laser scan of 67 and 90 degrees, and the melt pool is overlapped like this, overlaying of melt pool like this. Okay. So what happens? Inherited gas homogeneity, moisture, steady and dynamic melt pool flow, and a lack of melt pool overlaying can reduce the porosity and development. Okay, it reduces the pore in the case of hybrids. Hybrid structure shown good characteristics. Instead of these are all called unidirectional printing. This is bidirectional printing or multidirectional printing, whatever it is, we can name accordingly. But if you look at the sample, it will be laid in this direction for unidirectional printing, either 67-degree or 90-degree. But as far as I request that person to mute. There is some disturbance. Francis? Francis? Francis?
Sir, 1 second.
Okay. I think I can mute. Okay. Just a minute. there is one more Sendil Kumar and Mani. I think it is unmuted. Having some problem. Very difficult to. No problem. Okay. Yes. Francis, that Sendil Kumar and Mani, I think we have to mute that one. Hello. Francis? Yeah.
Sir,
The Sendil Kumar and Mani, I'm having problem with that.
Muted.
Okay, now it is muted. Okay, thank you. Okay. Just few minutes only. I'll finish it up. So, how we made a fretting wear test? Actually, most of the people we used to discuss always about pin on wear test, pin on disc wear test, pin on disc wear test. Wherever we go, we used to discuss with the pin on disc wear test, that is for a sliding wear. But in this case, this is a case study. Since this is a case study, we took fretting wear, which is a surface damage that occurs between two contacting surface, which gives to and fro motion. Likewise, it shows in the diagram. Okay. There are different types of frettings of the tangential, radial, rotational, torsional, etc. And this is the exact application in aircraft wing rivets, where we have to specify like this. Youngsters, those who are choosing problem, they have to specify the problem like this. I'm having this problem. There could be some problem. Okay. So these are the plates and rivets, how it is looks like. So this is what I'm rounding now. This is unidirectional flying. This is multi-directional or hybrid material. This is hybrid material. This is a normal material. Here the distortion will be more and the removal of material will be more. Whereas here the distortion is very reduced because the alternative layer reduces the subsequent layers, which is getting interlocked. The layers are getting interlocked, so it reduces damage. It reduces the damage. Practically, we experienced it successfully. We were able to produce a component with a higher degree of fretting wear resistance. Less shear stress in aircraft wing rivet. This is what we concluded, our study concluded, and we are moving to the second case study, which is currently now, which we are involved in. And another scholar named Mr. Daniel Devaraj is doing this research. We are in the phase, we are already 2 papers have been published with this. But we are waiting for thesis submission, but I want to share some of the experiences, what we did, how we managed to do our research in biomedical engineering. See here, the problems with the bio implants are clearly discussed. That is, there are under different categories, we can classify these problems associated with the bio implants. These are based totally on, with reference to some journals. Implant related complications, that is, higher biomaterial usage is associated with increased incidence of implant related complications due to poor implant integration. That is, the material ability to integrate with the bone. Solid metallic implants can face serious problems related to bone loss around the implantation site in load bearing applications. And metallic biomaterials wear, that is, aseptic loosening, metal ion leaching, and even toxicity. The toxicity means it is commonly, some people may have some allergic reactions if you are having some implants. And then immune response and hypersensitivity. It can be recognized by patients' immune system as foreign bodies. Suppose if you are making implant in your body, that is a foreign body. It may cause your cell and tissue immune responses, and it may lead to some kind of pain and a local soft tissue reaction and loosening of the implant, and lack of osteoconductivity. It is otherwise called as Osteointegration, different spellings are used. Then corrosion problems, because due to poor implant fixation, infection and mechanical failure. This is commonly happened. Normally, I experienced one of my colleague actually recently who met an accident last year, April. After 3 months, his leg got infected and his height got reduced 1 inch after retreatment because due to infection. It was a clear problem. Actually, so that's why it is very, very important. We have a lot of problems associated with, if it is not clearly diagnosed, if the bioimplants are not suited to your human body, definitely it would cause some infection. Okay. So this is a practical difficulty where I experienced with my friend, close friend, associate friend. So he got his height of one leg got reduced 1 inch reduced due to repairment. After repairing his, resurging, his height got reduced. So these are some of the important problems associated with the bioimplants. And most importantly, I don't know how many of you have come across the word stress shielding effect. It is not, it looks somewhat complicated, but it is very difficult, but it's very simple. You just look at, this is a femur bone. Just look at this arrow mark. This is the femur bone. This is the acetabular head. This is acetabular cup. Okay. So let us assume I'm placing a titanium or stainless steel implant here. This is stainless steel. The elastic modulus of this stainless steel, the stiffness, of course, of stainless steel implant is around 200. If it is manufactured through conventional manufacturing process, the elastic modulus of stainless steel implant is 200 gigapascal. Whereas for bone, it is 30. It is 30 gigapascal. Nearly 600%. There will be difference between this bone and this implant. So what happens? The stress given to this implant must be transferred to bone. Then only the bone will grow. Otherwise, then only the blood circulation will get into this bone areas. Otherwise, it will, this shields actually, this implant will shield the load. This protect the load entering, if all the human bones must experience some kind of load. Otherwise, the bone growth will be affected. This is what biomedical point of view, we have to look into that. It is a phenomenon that occurs when metal implants such as bone plates are used to repair fractures or in joint replacement surgery. The implant reduces the typical stress on the bone, which can lead to reduction in bone density. Actually, the bone density will be reduced if the stress is properly not distributed. This can loss of mineral density that increase the risk of periprosthetic fracture. Actually, the bone gets fractured. The adjacent bone will get fractured if stress shielding effect is not taken into consideration. Look out. The elastic modulus of stainless steel is around 200 gigapascal, whereas titanium is 110 gigapascal. For cobalt chromium, it is around 170 gigapascal. How to reduce this? The main problem is the stress shielding effect. Of course, nowadays, people are manufacturing these joints, implants through additive manufacturing. In olden days, they simply put stainless steel, even some plastics, ultra-high molecular weight polyethylene they have used. But what they might have done means, they might have done with some kind of alternating arrangements. That is, they might have increased the surface roughness. This is, I have just gathered from a journal where they have modified the surface roughness according to the adjacent bone for a stress shielding effect. But nowadays, it is clearly, we have the solution that the stress shielding effect can be reduced by additive manufacturing process. Let me explain how we can. So these are the ways to prevent stress shielding in bone implants. See, okay, increasing the bone implant contact ratio can help distribute the load more evenly between the implant and the surrounding bone, reducing stress shielding. This can be achieved through proper implant design and surgical techniques. I'll tell you clearly now. After reading this, I'll tell what we did to reduce the stress shielding effect. Improve implant surface roughness, modifying the surface roughness of the implant can influence the stress field in the periprosthetic bone tissue. A more optimized surface roughness can help reduce stress shielding and improve the long-term stability of the implant. We use materials with a closer match to bone. Now the closer match to bone is only beta type titanium, which is having low Young's modulus, that is 110 gigapascal, which is manufactured through conventional manufacturing process. I'll come back how we can reduce further this Young's modulus for titanium itself. And then functionally graded materials where alternating layers which have a gradual transition in mechanical properties from the implant to the surrounding bone. Even one of my scholars did this research on functionally graded material for bioimplants through centrifugal casting. He used magnesium-based composites where he used molybdenum and zinc as a functionally graded material. So the process is very cheaper. We got a lot of samples at the cost of around 20,000 or 15,000, something like that. Whereas in India, there is no functionally graded materials are manufactured through additive manufacturing. I'm sure, damn sure. It is only now possible only in Germany. So these are some of the challenges, how people are going to indulge in this kind of additive manufacturing. Definitely functionally graded materials will prevent the stress shielding in bone implants. But otherwise, those who want to do functionally graded materials can adopt centrifugal casting process where we can manufacture components with that prevents stress shielding in implants. And the best solution for reducing the stress shielding effect is to produce components with higher degree of porosity. That's all. This is the only solution. You produce a component with pores. That's all. If you have many pores, the density will be reduced. Inside the pores, the bone will grow and clump together. That stress attained by the implant will be shared to the bone effectively. But what is the exact percentage of porosity? We don't know. Still, it is in research process. Our study, we took 40, 50, 60% porosity. So for that, we have to develop a 3D model. There are two types of, there are a lot of structures available. Porous scaffold. This is diamond scaffold. This is gyroid structure. Of course, our research, my scholar did his research using this gyroid lattice structure. Using topology software, we were able to reduce. Just a minute. Okay. So we took this as a challenge and we used topology software to develop these lattice structures components. We did compression testing, not tension, and other hardness tests, corrosion tests, etc. We did. This is based on some other study. Look at this. This is a gyroid structure and this is diamond structure. So the Young's modulus is considerably reduced. The main objective of, see, in the case of aeronautical studies, you need to increase the you need to reduce the porosity. You need to increase the Young's modulus. Whereas for bioimplants, for biomedical applications, you have to reduce the Young's modulus. This is the difference. This is what the key role while selecting the material, while deriving the objectives or problem definition. So two different case studies. In one case study, you have reduced the porosity, whereas in the other study, you have increased the porosity and reduced the Young's modulus. This is the second case. This is what both the case studies have been done by us. Okay. So look at this, how the porosity plays vital role in Young's modulus. The 50% porosity is having good Young's modulus, but this is the optimal. This is the optimal. The porosity gets decreased with increased. What happens? Young's modulus. Okay, the optimum level of porosity is 50%, which also we derived through experimental procedure. Beyond that, we were unable to find the solution. Still, it is a challenging one. We have to find the exact percentage of porosity. It differs from material to material. Now, the current thrust area for, let me tell you, a lot of studies have been done in stainless steel. Please leave it. And we can do it in titanium and cobalt chromium alloys are the latest trends where the current research is going on. And we did our research and taking micro harness. Look at this. For this is cast titanium alloy, which is having 358 micro harness, whereas these are all gyroid structure with the porosity, which retain their, which increase their hardness, because this is metallurgical reasons, that is as cooling rates in lower temperature range when critical solid state phase transfer occur. As an outcome, the printed components often lack the necessary time to reach uniform microstructure. That is, fast temperature cycles frequently restrict the amount of some phase changes. In these cases, data from numerous sources accessible in the study literature enabled us to investigate the influence of AM factors on hardness variants and analyze the depth to which AM procedures allow for component hardness adaptation immediately after printing. But here the hardness, here I have given the hardness only, hardness, as well as we did a pin on disc wear test. In the previous case, we did fretting wear test. The application is totally suitable for aeronautical application. But in this case, actually, this wear test should be done on a hip joint simulator, which was designed by us actually earlier, but it was not under working conditions. So we switched over to pin on disc. So if you look at this, sample C, sample B, and sample A. This is as the porosity increases, the coefficient of friction also increases. Here, look at this. The sample C is having very less wear rate when compared to others because it is having 60% of porosity. That is, it has good wear resistance, even though it is having higher coefficient of friction. Why? We used to, technically speaking, people used to think that the coefficient of friction is directly proportional to wear rate, but that is not the case. The particles, some of the detached particles might come into contact with the contacting asperities that might act as a lubricant, solid lubricant to reduce the wear rate. So generally, as a blind theory, people used to thumb rule. Coefficient of friction is directly proportional to wear rate. That is not the case in case of pin on disc wear test, sliding wear test. The wear particle abrasive might have acted as, this is a lot of references are there. Even I published more papers, 30 to 35 papers on this area on itself. So in some cases, coefficient of friction will be or shall be inversely proportional to the wear resistance or wear rate. Okay, you better use any one thing, either wear rate or wear resistance. So this shows how the velocity make an impact on this coefficient of friction and the wear rate. And these are some of the sim pictures. What kind of mechanism we obtained for this oxide layers, how the crack is initiated. Here the ploughing type of mechanism. Here the grooving Here the materials have been delaminated out the scratch, and we found some oxide particles. These are some of the kind of wear mechanisms we obtained, and these are some of the theoretical part which I don't want to go because already we lapsed more time on this one. And I hope by this presentation I might have given some glimpse about additive manufacturing and research caps. Maybe simply we can classify either. Don't choose blindly an additive manufacturing and do all the tests, tension, compression, and tribological. Don't do the test like that. Select the problem, derive the objectives, then derive the work plan, and then do it. In the first part, we did tensile studies. In the second part, we did compression studies. In the first part, the first case study, we did printing wear test. In the second part, we did sliding wear or pin and disc wear test. So based on the applications and the problems only, you have to select your research area. And whatever the knowledge I gather, I share. Before that, I want to thank my scholars, Dr. Bintu Sumant, who was instrumental in preparing this, even slides, of course, and my research scholar, Mr. Daniel, who is sitting nearby. Actually, all of them helped in preparing this. Okay, I'm thankful. Even if you have doubts that are unclear by me, my scholar who are sitting, actually, who are present here, maybe Bintu is there, I don't know. If he's there, he would, we are ready to clarify all the doubts technically, as well as, and we are ready to guide you if you want to pursue research in additive manufacturing. You can talk to me, or you can contact. I'm having my email already. Maybe you can take a phone number from my scholar, Dr. Francis Luther King. Okay. And with this, I'm concluding this session. And thank you for the opportunity you have given. But before that, please, students, raise some questions. And I hand over the mic to Francis. Francis, thank you. Are you there?
Thank you, sir.
Thank
you, sir.
Yes.
So, dear participants, if you have any queries related to additive manufacturing, so you can post your questions. You can unmute yourself and you can post your questions.
Any questions? Even if I feel maybe even complicated questions, maybe I cannot claim that I was an expert. I'm an expert in this area. Recently we have started. That would help me also to develop my skills and knowledge in this area. So for that purpose, I'm asking. Any questions? Please raise questions only. Yeah. Kindly introduce yourself.
Yes. I'm Srinivasan. Again.
Very good. Yes.
As I am from Dindigul. So, but nowadays, the most of the research in bioimplants are going towards magnesium alloys rather than the titanium or cobalt or this stainless steel alloys.
Okay.
So, is there any work present in India about this magnesium alloys, particularly with 3D printing?
Additive printing of magnesium alloys, people are not preferring actually generally. They say they are having some complexity. They don't want to take risk actually. In foreign countries, they are doing all kind of researches. But in India, we tried almost all over the north to south, east to west. They have some specific limitations. They are ready to do certain, even in National Institute of Technology, they are ready to do it for stainless steel and titanium, not titanium even, stainless steel and aluminum. They are not ready to do with the titanium. The cost of titanium and other things are restricted. They're restricting them. If they want in bulk quantity, then they can do. Some other institutions are there where they can print titanium. And now we are trying with the cobalt chromium actually, which is the third student has registered under me. She's pursuing a research on cobalt chromium. And both first paper, it is Inconel 718. Am I right? That is for aeronautical applications. That is also possible. But whatever the material, you are talking about bioimplants. My suggestion is bioimplants. if you are going for bioimplants in additive manufacturing, only titanium and cobalt chromium are available currently. Otherwise, if you think, definitely it is 10 to 15 folds costlier than conventional casting process. Functionally graded material where you can develop a magnesium. This is my suggestion out of this topic. If you want to do for functionally graded material that you want to reduce the stress shielding effect, you just try it in magnesium. That is a new area where we have also tried actually. We got successful.
Because the density is very low here, isn't it?
Yeah, that is good. We need lesser density only. At the same time, we should not compensate. We need minimum strength only. The desired property of the bioimplant is we need hardness. It won't bother because hardness higher means wear resistance should be good actually, because there will be some sliding parts. So besides that, you are having compressive strength. You are going to test the compressive strength, and then the porosity should be higher, so such that it enables the bone to grow. That is very important. See, simply removing the damaged spot and putting an implant is the easiest thing in the app. But after that, how many years it would sustain? That is important question. Nobody will answer. All the implants, what we are doing is based on foreign researchers. We don't have any thorough data or thorough research because we need more facilities in India, frankly speaking. Okay, the cost of research is very, very, very too much. Yes.
So, but particularly when you are saying about the bone, if you are replacing with a bone implant or it is equivalent to bone actually, if you are saying about the porosity, we are going to choose porosity of equal size or whatever the thing. But in real cases, in real bone, it will not be like that. It will be in a very random manner.
No, the tissue will fill the porous areas. Okay, that is the reason why we are behind. It is successfully implemented. That porous areas that will be filled by tissues. So that will keep tight the bone actually. Definitely, stress shielding is an important criteria, and one for topmost criteria, stress shielding. That should be addressed. Without addressing that, going for because I didn't put the statistics. The failure of implants or the lifetime of implants is almost 10 to 15 years only in India. Currently, I studied. I don't have any data, but I studied actually. We need to increase the time cycle.
Sir, we have one question in the chat.
Thank you, sir.
Thank you, Srinivasan. Okay. Yeah, Francis.
In India, is AM, additive manufacturing, used in medical science like AIMS or in industry?
Okay. That is the question. Which area in AIMS or industries? Huh?
Yes, sir.
Yeah, private industries.
Yes, additive manufacturing used in medical.
Medical. Yes. Medical fields, but
medical science like AIMS or in industry.
See, they are the implants are manufactured from private companies only. They are getting implants from private. Even my close relative got into. She got their implants from private industry only, not from any government sources or there is no government institutions producing this component commercially now.
I think Germany is the leader, I think. Isn't it, sir?
That I don't know, but yesterday I just discussed with one of my colleague, not one of my colleague, one of my student actually. He told me that Germany and in Singapore also they are producing vast varieties of these things. Well, even in Japan, there will not be any restriction. In US, that is not a problem. In India, the cost of manufacturing is very, very high. If we produce the same component within 10,000 or 5,000 in magnesium or titanium, whatever it is here, if we go for additive manufacturing, it goes around. Even both the students have spent more than 2 lakhs, nearly 2 lakhs for that component manufacturing itself. We need that optimization of process parameters is very important, where we need higher degree of wide comprehensive studies are necessary. Optimization of parameter is a big issue actually, but we choose someone's optimized parameter and we are doing it. Okay. For aeronautical applications, other things, the optimization of process parameters is very important. Further, you need wider degree of research which would cost more around 5 lakhs or 10 lakhs, something like that. It would go if you want to go for optimizing the process parameters. As far as the bio implants, there is no need for optimizing the process parameters. Already we are not going to enhance the mechanical properties. We are going to step down the desired properties. So that's why the optimizing process parameters. So that's why I took 2 different case studies actually. One is a different tensile strength and enhancing the mechanical properties, and another one is decreasing the mechanical properties. So that's why I gave 2 different scenarios, the same process.
Okay, thank you, sir.
Thank you, Francis.
For your
thank you for
insightful information about additive manufacturing. So, on behalf
thank you
of
for you actually.
Department of Mechanical Engineering, and on my own behalf, and on my behalf of organizing committee,
Yes.
Having accepted our invitation with a short notice, and you have given a contentful resource as well as for the researchers by giving 2 case studies. Thank you so much.
Thank you, Francis, for giving me this opportunity. Since I didn't produce give any lecture on this actually, I compiled all my students' work actually. I have to thankful to them. Likewise, I'm very happy to have such a nice student like you who gave me this opportunity to share this knowledge. Any help if you need, the scholars need, they can reach me through phone or email whenever. Thank you. I think this is the right time to close my session because there's another expert is waiting online. So shall I close the session? Thank you. Thank you.
Yes, sir.
Thank you. Thank you.
Thank you, sir.
Thank you. Okay.
So, dear participants, we have the second session by Dr. V. Kandavel, Associate Professor, Department of Mechanical Engineering, SSM Institute of Engineering and Technology, Dindigul. So, in another 2 minutes, we can start the session.
Good evening, sir.
Kandavel, sir.
Yes, sir. I'm available. Good evening, sir. Shall I start, sir?
Sir, you can. Yes, sir. You can share your screen.
Oh, yes, sir. Sure. Sir,
Yes, sir, visible, sir.
Visible, sir, but make it full screen, sir.
yes, sir.
Yes, sir. Visible, but make it full screen.
Is it okay, sir? No?
Yeah, fine, sir. Fine.
Yes, sir. Okay, sir. Welcome.
Yeah, wait, sir.
To all.
So, wait,
Okay, sir.
sir,
Shall I
just
start?
a minute, sir.
All are available. Okay. Thank you.
So it's my happy privilege to introduce Dr. V. Kandavel, sir, Associate Professor. Sir has completed his PhD in manufacturing from Anna University, Chennai. Having a vast experience, he has published various journals, papers in national and international conferences, and awarded with MECH&ROBO by IIT Bombay during 2015. With overall experience, Sir has published international and national conferences. His area of interest includes manufacturing, supply chain management, CAD/CAM, and composites. Sir is also a member in various organizations, and he having rich experience in academia as well as in industry. So with this few introduction, I now give away the session to Professor Dr. V. Kandavel, sir. Sir, please.
Thank you, sir. Thank you. Once again. So, good evening, professors. Little it's about my. So, I am Dr. V. Kandavel, Associate Professor in the Department of Mechanical Engineering, SSM Institute of Technology, Dindigul, Tamilnadu. So already sir is little expert about me. So in addition, so I completed my UG degree in 1998, sir, from Madurai Kamaraj University, Organised College of Engineering Technology. And I did my PG is 2010 MECH&ROBO, and I received a doctoral degree and optimized the title of optimization and the modeling of dynamic facility location, allocation, the relocation using fuzzy and graph theory. So from Annamalai, Chennai, and year 2018. So I have 13 years of teaching experience and 9 years of industrial experience in the field of erection, commission, planning in the industry. So my research interests are in manufacturing, supply chain, and recent advancement of mechanical engineering. I see. So in addition, go to the my little aware about the facility location and allocation of that is using fuzzy and graph theory. It's my one of the research topic. So shall I explain for that one? So this is the topic of application of fuzzy logic and graph theory for dynamic facility location. So the dynamic facility location problem. Sorry. So first, the facility location and the decision of an organization have a long-term impact. So the main impact is to manufacturing industry. So very expensive to shut down the facility or move it to different location. And we know that the good location decision can help to improve the responsiveness of the demand while keeping its cost low, which will maximize the profit. The decisions related to locating the facility influenced by various factors. So some of them are a technological factor, infrastructure factor, customer response time, logic, and facility. So, and it is critical and important to determine the optimal location for facilities. Right, sir? So, the dynamic facility location problems have been extensively studied by the lecture research and apart some more research due to its various practical applications. So that many literatures as have been carried out in the different location. These facility location problems have not been classified previously, which limits the study of issues specifically related to dynamic facility location. So the facility location problem are classified herein. The classification reveals the past current trends in DFL, that means dynamic facility location, and point out the possible research areas that include the formulation of objective function and model of formation. This is the major criteria that formation of the problem in my research. So this research work focuses on the development of the methodology for solving dynamic facility location problem while considering all issues related to the real-time facility location. The fuzzy logic-based approach and the graph theory have been proposed to solve dynamic facility location problem. The performance of two methodologies are compared and analyzed for solving the dynamic facility location problem. From comparison, it conclude that the large size problem are easily solved by fuzzy and where the small size problem are solved by graph theory. It's a very important there is a large size problem is easily solved fuzzy and a small size problems are solved by graph theory. So this so these are the simple keywords. These are the supply chain management, facility location, dynamic facility location, graph theory, and fuzzy logic. So the firm must decide where the facility should be located. or where to relocate existing facilities. This is the main task of our recent criteria in any business. So facility location problem deals with the decision of locating the facility, which can be plant, warehouse, distribution center, or etc. So these are the facilities. Facilities are the plant, warehouse, distribution center, etc. So hence the decision related to the location, the facility is a strategic decision, particularly for the service organization. So in which the location of supply sources and markets, location of potential facility sites. So demand forecast by the markets, facility labor and material cost by site. So cost of transportation, the cost between each pair of sites, inventory cost by site as well as the function quantity, sales price, production of different regions. So they say response time. So other service factors are important. So while establishing facility in the main concern is to minimize the cost, to maximize the profit. So there's a literature in saying it all 2006. The facilitation problem are commonly modeled mathematically and they are solved to find the optimal placement of facilities in order to minimize the transportation cost. So Kramer-Weber problem is simply facility location problem in which the single facility is to be placed with a minimization of the sum of the distance from the given set of point sites. Next, the more complex problems are in previous the single problem. Now we go for the more complex problem considers in the discipline include the placement of multiple facilities. So constrained on the location of facilities and the optimization criteria, the facility location problem generally consists of set of potential facilities. Right. So L is the facility can be open and the set of demand point is a D of the service. So simply say. So the objective is to pick this subset here from the facility to open the sum of distance from each demand points to its nearest facility and minimize the sum of opening cost of facility. Right? So now it's a supply chain management. It's a major part. Now the supply chain management is the flow of goods, which includes the movement and the inventories of the raw material and inventory work in progress from point of origin to point of consumption. So supply chain management, so they include the decision, planning, execution, control, and monitoring of the supply chain activities with the objective of creating net value, building the competitive infrastructure, leverage worldwide logistics, synchronize the supply with the demand and measuring performance globally. So this is the main criteria and the subsystem of the facility location. So supply chain, the major part, the supply chain is the alignment of firms that brings product or service to market. It consists of all stages involved, directly or indirectly, in fulfilling the customer's request. So the supply chain is not only includes the manufacturer and supplier, but also the transporters, warehouser, retailer, and customers. So this is a simple schematic view: the supplier, manufacturer, then distributor and retailer. In distributor retailer is from direct to customer. So this is the network, simply the supply chain management. So reason for dynamic facility location problem. Why we go for dynamic facility location? The time is concerned. The time is concerned the major element. The depending upon the time, facility can be changed. So static facility location problem can be transformed to an equivalent problem to dynamic facility location problem. So both of the space and time can be analyzed by the discrete and continuous aspects. So we know that very well that the dynamic part is changed into static. That is then only we solve the problem, isn't it? So dynamic model have leading role in strategic planning and decision making for special location problem, and they are gradually becoming more important due to that vessel location problem. So the advantages of the dynamic vessel location. So there are a lot of advantages. The dynamic vessel location not only looks for the optimal location of facilities, but also tries to optimal assign their facilities to customers in order to fulfill their demand. So this problem minimizes the total cost incurred by the allocation of trains. So dynamic vessel location problem is to locate the set of new facilities such that the transportation cost from facilities to customer is minimized. So in capacity problem, the allocation of facilities to customer so may be constrained due to capacity, the limitation of facilities. Okay. Then the literature review, then some of finding the gaps between the vessel location problems have been extensively researched in the last 3 decades, which presented in this literature. The facility location problem are widely studied. The optimization problems, the different types of facility location, analyze problem, allocation problem, or location problems discussed in the literature can be found in the book Water 2011. So the plant or warehouse, the location problems which can also be named are uncapacited facility location problem, which aim to find the optimum number of locations and facilities that minimize the total traveling cost and facility opening cost, and the considered central facilities with the location of the period of minimize with the facilities. Then the problem related to space alone are called as static. And those who portend the both space and time or dynamic. So we know the difference between static and dynamic. So based on this, the physical location problem can be classified in the literature. Adaboni and Parani for the base paper of literature 2012, the static facility location problem and dynamic facility location problem. So many researchers address the static facility location problem considering the conditions such as continuous space, discrete space, and network space location problem. So real data 2008. So the methodology of research work is represented periodically in the following year. It's to provide a detailed approach to the problem. So the physical location will have the possible functions. In the future, changing the parameters can be handled efficiently with a dynamic model rather than static. So this is mentioned in Arboni and Farhan in 2012. This work concentrated on dynamic facility location problem. So there's a research gap. The main concept is dynamic facility location problem classified into two, one as mathematical approach and another one the solution methodologies. So there are a lot of mathematical approaches there. One is quadratic problem, branch and bound, binary based variable, integer program, linear program, and graph theory mode. So the integer programming further into two categories, and linear programming is further into three. Then solution methodology, there are four: exact procedure, heuristic, meta-heuristic, possibility. We know very well the exact procedure and heuristics are some anthropology meta-heuristics, simulated animals like this. So fuzzy logic will be solution methodology for dynamic facility location problem for large sets, and graph theory model is the methodology for using the small size problem. So, in order to carry out further studies in the case of dynamic facility location problem based on the available research gap in the literature, this section brings some research and development. So, one of the areas required more attention and how to combine continuous models with the dynamic problems. So at the first glance, it might be perceived that the essence of dynamic problem depends on the discrete models. So even though the interaction of the continuous model with a dynamic problem can facilitate favorable results are discussed here. So it is also notable that we ignored parameters such as availability, utility, and other criteria shall lead the study to location and allocation relocations. Therefore, the parameter of minimizing the cost for distance is only considered. The cost is the consider for the distance. The next, the main objective of research, according to the literature review and the difference between the objective of this previous surveys, which were solely based on the specific objective of this research work as follows. First objective was minimization of cost, time, distance, risk, systematic procedure and model can also be broadened to build additional point of the separation and literature by their performance. So approaches and applications where more practice can also be included. Yeah. Then to determine the uncertainty of the maximum location problem, thereby the large volume of surveys carried out here. So analyzing and justifying the principle of control limitation both we have a graph theory model and the fuzzy and a performance. And the secondary purpose is to reduce the cost of materials in the terms of movement from the source to product. It's a very, very important one. Next, that's the graph theory model for a small size problem. So graph theory, we know that very well that the mathematical representation diagram, and it's a branch of mathematics is taught in the early my 17th articles. It took 100 years before the second important computational which was been made for the analysis of the electrical network. So graph theory has found many applications in engineering and science as a chemical and civil electrical mechanical engineering. So the communication of this graphical theory, the main objective function of has not been truly considered neither from the viewpoint of model analysis, the computational complexity, the classification nor from the viewpoint of the algorithm nor plus both theoretical and practical considerations that suggests it would be an worth studying. So some of them can be found in the atmospheric approach and proposed for the location problem on trees. Mainly the graph theory trees model. So finally compare the solution of fuzzy and graph theory where the one of the dynamic cluster analysis. Through an example, let's suppose that the use of fuzzy graph theory solving these problems can be decreased by calculating the scale and time evidently, especially when the fuzzy equivalent matrix can be this algorithm for calculating. So this is the main objective function of the graph theory model. So minimum of Z. So these are the regulative functions where Z is traveling cost, T1 as the transporting distance, Tj is the demand, I is the that 1 to 3 as the distance traveled between the locations, and J is the demand between the locations. I is the distance traveled between locations, J is the demand in between the locations. So subjected to capacity of warehouse is equal to demand for the customer. This is object one of this assumption. Where our page travel distance should be limited. So this is the simple graph theory matrix. We know that very well. So V1, V2 are the vertices. The cities come from this matrix is distance is traveled each action and construct another matrix in the terms of demand. So there's a shortcut is spanning between the graph hard and by computer. Then we solve the small size problem of the location. And Then comes the last type of problem. Recently, the purpose of fuzzy in the special locations, the very promising and different fuzzy approaches have been employed. New results 2008 and solved by the supply chain network creation problem. The Chinese liquor industry, that is a beverage industry, using the multi-objective mixed integer programming model to minimize total cost and maximize customer services. Finally, based on the fuzzy subjective attributes, weight, the fuzzy model has less complexity, both market supply and customer demands of detects the fuzzy variables in the model. So, feasibility ensures the in-house criterion are introduced to convert the model into NP hard model and to solve the model. So this the problem is NP hard that here and all that. Then many researchers have externally deliberated with the specific location on problem in the deterministic model. Okay, the following cases very important for the specific locations and problem. So the main objective function of the fuzzy model, C of xy is equal to minimum of xy belongs to z. Summation of I tends to 1. So that is a simple distance calculation xi minus aj square plus y minus bj square. Subjected to sigma is equal to 1 research is equal to epsilon to upon j. Then similarly the subject to another assumption. So in this model there are the facilities and m customers. Furthermore, xi yi denotes the location of facilities. That is 1 less than less than or equal to n. That is a bj stands for the location of customers. J1 less than j and less than m. This is for the facility. Whose capacity is ui supplies the Zij units for customers j, and n is the random passing demand of customers j. Concerning this model and the objective function, let's say equation 1 and minimize transportation cost. Then equation 2 identifies the satisfies levels. So similarly, and equation 3. Then this is the methodology for the fuzzy model. So once start, then selecting attribute, then comes under allocating the preference order. Then it is the same attributes. If yes, then go further. Otherwise, in the same repeat the selecting attribute. Then calculating the preference degree. Then comes on the set. Then comes ordering the set. Order the set. Then comparison of the largest and the inverse set. If another comes comparison of total and second largest set. Then finally preference order. Then the conditions unique compatible order. No, then further it is comparison largest and universal model. And if yes, it's a so this is the methodology for fuzzy model of facility location problem. So some of the result and discussions. So total cost is like this. The y-axis and the kilometer, the distance, and this special location that model. Therefore, the simple graph is plotted showing above the graph relationship between the distance and total cost. So the final setup is the development of the solution using next. The another one that is very important that is a result that has been gained from the 3D plotter is assumed to be the theoretical value which can be implemented and any practical decision making progress to save this time. And it also helps to reduce the cost. Okay, this is the 3D plot model, and it's a total cost in y-axis and horizontal, and z-axis is z, and x-axis is initial cost. This is a minimization model. And also there is another extent representing of saving some initial cost in account goods that output shown from the graph provides the detailed and precise values in a simple and brief facility location. This resultant peak point which is obtained near the front bottom of the means that the solution is optimal and can be used the better solutions. So this another order explains the fact when the value gets increased the following platter or taken into account. The platter value is simply described and the result that is the most appropriate, most suitable for the decision making for increasing the initial cost and the power risk, and this is the very less impact on it. So another important result shows that the value of the peak point is in the extreme condition. I think unsuitable for selecting the decision for the regular location. The value of all graphical model are explained by very 3D graphical curve. Whenever the curve was the beginning, the decision is good. And go and where the value is in a mid-region, there and the dilemma. And the finally when the origin considerably the model for the good. Okay. So as for the simple calculation, the results and discussions, the main conclusion of this work comprises the three phases. First one is the dynamic selection of the preference. Second, the formulation of suitable method and to solve the problem. And third is usage of solver to have a brief analysis. So whenever a problem arises in a small, medium scale industries, in accordance to the specific location, all acts are taken in account. So and the decision is made in a pure theoretical manner, which time saving help in the locations. So this work is reviewed with two different approaches to originate and integrated location or routing model. The set of customers and their demands will change the daily resulting in daily route changes, while the facility are likely to be fixed for years. Okay. The main objective of this problem is to maximize the serviceability and minimize the transportation cost. The main objective, maximize the serviceability and minimize the transportation cost and the average traveling distance. The minimum traveling distance of the calculated by the tool graph theory and using the objective function in the minimum or minimum. Okay. So further, the problem of selecting the preference can be solved in the event of having the fuzzy about the preference. The accuracy of the results obtained through the fuzzy algorithm is higher than the results obtained through the optimization methods, and it can be used to solve the real demand multiple facility locations. And the use of obtained at the transportation cost performance, the existing network can be improved by the combined facility location. Combined facility location. These are the extended work. So these are some references. Main review papers are Godavari and Farah papers as well. These are the main review papers. And then further a lot of research papers is shown here. So it's a deviator from our FDP, different topic.
Hello.
Yes, sir. So thank you very much, management staff of SWarnandhra College of Engineering and Technology, and our active participation of this team, the faculty development. Thank you, sir.
Thank you, sir.
It's a hectic time
Thank
for
you very much.
dinner time. Thank you, sir.
Thank you, sir. Thank you.
Any queries?
So, dear participants, if you have any queries, you can unmute yourself and you can raise your question.
Sir, one question, sir.
Oh, sorry,
Hello.
sir.
Hello,
Yes,
sir.
sir.
I'm Dr. R. Sanjeev Kumar from SWarnandhra Engineering College.
Yes, sir. Yes, sir. Okay.
Is it
Thank you
possible
for
to
welcome.
solve the uncapacitated facility location problem in fuzzy logic, sir?
Yes, sir. Sure,
Is
sir.
it possible
But
to solve?
yes, it's possible, sir. Possible. But it is
Then what?
the subjective of assumptions that we will set one. Then only possible to solve the uncapacitated problem. Is it possible?
Okay, sir. So if it is possible now, what about the termination criteria, sir? You
Actually, the
explained in the
recent
flow chart.
yes, sir. Yes, sir. Actually, the recent literature is well versed in that. Okay, just a minute. Sorry.
Hello.
Yes, sir. Just a minute, sir.
Hello, sir.
In that
Is
flow
it
chart. Yes, sir. Is it possible that criteria means you mentioned? Just a minute, sir. Maximum.
termination criteria means when we will get that solution at what conditions it will exit that loop.
Sir, yes, sir. Actually, that final preference order, isn't it? Okay, sir.
Oh,
In that
okay, sir.
area, that termination criteria is possible that data. Then our assumptions, these are the assumptions where, okay. The subjective to that, the assumptions is a relative elaborate level. Then only we solve the uncapacitated problems in the assumption that is fuzzy model, using this fuzzy model.
Okay, sir. Okay, sir. Then one more thing, sir. One more
Okay,
thing.
sir.
To find the best solution, which method we should use? Whether we should use the mathematical approach or solution methodology. That means fuzzy logic or meta-heuristic. Which method we will get the best solution, sir?
Fuzzy method, sir, because I'll explain in detail literature also. These are the methods for the near optimal problem solutions. These are
Near
the that
optimal.
mathematical near optimal, that is fuzzy what is this integer programming, linear programming methods. So this one, but exact solution methods was there, and even fuzzy also get a prompt optimal solution. So
Okay, sir.
heuristic and meta-heuristics are near optimal solutions. That is may or less sometimes.
Oh, okay, okay, sir. For large size problem, we will use this
Use
fuzzy logic and
fuzzy logic,
meta-heuristic.
right? Yes, sir.
Okay, sir. Thank you, sir.
Thank you, Mr.
Mr. Sanjeev,
Tell me, sir.
the model itself is fuzzy model.
Okay, sir.
So we can solve it only by fuzzy means, not by any meta-heuristic methods. It is a mathematical model.
Hello. Hello, sir.
If it is a mathematical model, simple mathematical model, then you can go for your meta-heuristic methods. But the problem itself is fuzzy actually, and the model itself is a fuzzy model. So you can seek the fuzzy solutions only.
Okay, sir. Okay, sir. Thank you, sir. Thank you.
Thank you, sir.
Thank you very much, sir, for your expertise in this fuzzy
Thank you very much, sir.
and facility location. I hope the participants have come up with the best session today. So on behalf of SWarnandhra College of Engineering and Technology, Department of Mechanical Engineering, and on behalf of the organizing committee, I sincerely thank for your valuable presentation and insight about facility location problem. Thank you.
Thank you, sir. Thank you, sir. Thank you very much, sir.
Thank you, sir. Thank you.
So, dear participants, the attendance and feedback links are posted in the chat box. You can fill up It will be active for next 15 minutes. So kindly fill up the session feedback form. And tomorrow, day 3, we have 2 sessions. Session 1 by Dr. Gopinath, Professor, VIT University, Vellore. The topic is role of learning algorithms in defect detection, followed by second session by Dr. R.T. Gopi, Professor, VIT University, Vellore. The topic is hands-on learning algorithms in defect detection. Feedback form, which is posted in the chat box, YouTube live session, as well as in the Zoom chat box. This feedback form will be active for the next 10 minutes. So thank you for your active program, and thank you so much for your active participation and learning. So kindly fill up the feedback form. It will be active for another 5 minutes. Thank you.